in Noida Institute of Engineering and Technology, Greater Noida Pharmacy Institute. Today I am going to discuss on the topic that is optical rotation from our subject, that is physical pharmaceutics, belonging to the code that is BP302T. So, in our earlier or previous classes we already discussed about the various topic from our second unit. Okay, likewise the state of matter, different states of matter, that is solid, liquid, gas. Okay, then we already discussed the polymorphism, amorphism, physiochemical property of drug substance. Okay, so by that today I am moving on our next topic, that is our optical rotation. So, what is optical rotation? You can clearly see on the board that is optical rotation or optical activity. We can refer it to as an rotatory polarization. What is this? It is the rotation of the plane of polarization of linearly polarized light as it travels through a certain material. Okay, when a light travels from a certain material, it rotates according to the polarity or according to the polarization and the plane of polarization. By that we had a diffraction, by that diffraction we can assume the rotation of that particular lights. So, that optical rotation, or we can say optical activity, is the rotation of plane of polarization of linearly polarized light as it travels through a certain materials. Optical activity can occur only in chiral materials, okay, those which are lacking in microscopic mirror symmetry. What do you mean by microscopic mirror symmetry? That means substance which do not have mirror image, same image, which you already know, है ना. What we have mirror image, like if a compound having same mirror image, that is symmetric, if it is not then it is asymmetric. Okay. So, unlike the other sources of birefringence which alter a beam of state of polarization, optical activity can be absorbed in the fluids. Now, here I would like to ask about what is birefringence, as I already discussed this in our previous class. What is birefringence? Birefringence, it is that it is the optical activity of a material, right, which is having a refractive index which depends on the polarization or propagation of the lights. ठीक है, यही तो था birefringence, हमने पिछली बार बताया था आपको. So, moving to the next, we have that this birefringence which alter a beam's state of polarization, optical activity can be observed in the fluid. Okay. So, this can be include gases, okay, or solutions of chiral molecules such as we have sugars, okay, molecules with helical secondary structures, as some proteins and other also are there, that are some chiral liquid crystals. Okay. So, from here we can have, it can also be observed in the chiral solutions such as certain crystals with a rotation between adjacent crystal planes और अ मेटा मटेरियल्स. तो एडजेसेंट प्लेन क्रिस्टल्स में हमारे क्वार्ट्ज हो सकते हैं. ठीक है. नाउ रोटेशन ऑफ लाइट्स प्लेन ऑफ पोलराइजेशन में ऑल्सो अकर दो द फैराडेज इफेक्ट. यू ऑलरेडी नो द फैराडे इफेक्ट, राइट, which involves a static magnetic field. However, this is a distinct phenomena that is not usually classified under the optical activity. So, this phenomena is not basically comes under the optical activity, but we can explain it by the Faraday equation. So, polarimeter are the optical instrument for measuring the rotation or twisting of light. So, if someone asks you how you can measure the optical rotation or how you can identify the optical rotation, you can simply say that there is an instrument which is named as polarimeter. By that we can explain or we can identify the measurement of the rotation or the twisting of any kind of light. Okay. So, moving forward, we have the industrial and academic laboratories which are used polarimeters for a variety of purpose, which is ranging from a simple quality control to a fundamental research into a complex chemical structure. So, here you can see a diagram which I have already mentioned in the slide. Like in industry or in academic laboratories, we always use polarimeter to measure the length or to measure the optical activity of a light. So, in industry or in academics, we use polarimeter for the purpose to identify simple quality control parameter of an light, okay, or if we are doing any kind of fundamental research of very complex chemical structure, if the chemical structure of a compound is very complex, then we use the polarimeter to identify the optical rotation in a particular compound. Okay. So, here you can see that we already mentioned the diagram. Here you can see a monochromatic light source is there. Monochromatic light source is that which diffracts the light or which can divides the light according to the speed or the form of a light. Now, here we have an ordinary light, okay, that is ordinary means this is the natural light which is coming, and by the help of monochromator it will diffract or bisects in the part, and then it comes to the ordinary light. Here we have a polarizer, okay, which can polarize the light. Okay. Now, here we have one refraction mixture instrument, that this is the refraction mixture instrument, okay, we can say polarimeter tube, it is this. Here we have a plane polarized light, a beam that is dissecting here as in this form, and in this we have optically active substance in solution which causes the plane of polarization light to rotate. Okay. That light which comes from the monochromator and the ordinary light is rotated in this polarimeter tube. Here some lights comes from the direction of the propagation of radiation and then moving to an analyzer. Analyzer is there to analyze the lights, and here we have the observer observes the optical rotation of that particular compound. Okay. So, moving forward, we have methods of determination of optical activity. What are the methods of determination of optical activity? How we can determine optical activity? Okay. So, here simply it is mentioned that optical activity is measured using polarimeter, which I already discussed. पोलैरीमीटर एक इंस्ट्रूमेंट है जिसको हम अपने लैब में, अकेडमिक्स में, इंडस्ट्रीज में, either in research purpose where we have very complex chemical compounds, we use polarimeter, okay, to identify the optical rotation or optical activities. So, what does it contain? How does it works? These are the important question for that polarimeter. कि polarimeter है क्या, है ना? How does it works? कैसे करता है? काम कैसे होता है? Okay. So, moving to the next, we have it contain two polarizing elements. Okay. So, firstly it has two elements in which one of which is fixed and other is an analyzer. तो दो instruments हैं इसमें, ठीक है, दो elements होंगे. जो elements की बात की जा रही है उसमें एक element तो fixed है, दूसरा हमारे पास analyzer है which analyze the activity of the light. Now, it can be rotated and mounted within a graduated circular scale in order to measure its orientations with respect to the polarizer. Okay. So, इसमें क्या एक माउंटेन ग्रेजुएटेड सर्कुलर स्केल है जो आपको इससे पहले बताया कि पोलैरीमीटर मेजरिंग इंस्ट्रूमेंट टाइप का. उसमें क्या होता है, आप लाइट की ओरिएंटेशन के हिसाब से with the help of polarizer you can, that light rotates inside it and that according to the polarization it comes to the observer. Okay. So, when the plane of polarization of two elements, and here elements can be as prism, okay, are mutually perpendicular, no light is transmitted through the system. यहाँ पे बात ये की जा रही है कि अगर आपके पास जो दो एलिमेंट्स हैं वो प्रिज्म है और प्रिज्म जो है वो आपस में परपेंडिकुलर है, तो जो भी आपकी लाइट आ रही है फ्रॉम द प्लेन ऑफ पोलराइजेशन, दैट लाइट इज कमिंग, एंड इफ योर इंस्ट्रूमेंट इज or your element is prism and they are perpendicular in their arrangement, mutually in perpendicular, then there is no transmission of light in the system. So, ये सबसे पहली चीज़ है ध्यान रखने की कि अगर आपके पास एलिमेंट प्रिज्म है और उनका जो अरेंजमेंट है, क्योंकि पहले ऊपर पॉइंट में क्या है आपका टू एलिमेंट्स हैं, एक हमारा फिक्स्ड है और दूसरा हमारा एनालाइजर है, लेकिन दूसरे में यहाँ ये जो बात बताई जा रही है दैट इज द थिंग इज कि अगर टू एलिमेंट्स हैं जो कि प्रिज्म है और उन दोनों की अरेंजमेंट परपेंडिकुलर है, तो जो भी आपकी लाइट आ रही है प्लेन ऑफ पोलराइजेशन लाइट, इट विल नॉट ट्रांसमिट एनी काइंड ऑफ लाइट टू द सिस्टम. तो आप ऑप्टिकल एक्टिविटी उस कंपाउंड की पता ही नहीं कर सकते हैं. द पैरामीटर टू टेक इन कंसिडरेशन इज दैट द अरेंजमेंट ऑफ द एलिमेंट्स, ओके, शुड बी वेरी 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 केयरफुली. नाउ moving to the next, light can be directly filled in the sample tube if the substance is solid, accurately weighed, portion is transmitted into the volumetric flask and dissolved in water or other solvent as it is specified. So here the thing is that if a liquid is filled in the sample tube, okay, और अगर substance हमारा solid है तो हम क्या करेंगे, उसके अकॉर्डिंग ही उतना ही वेट प्रपोर्शन का जो भी अमाउंट सॉलिड का होगा वो ट्रांसफर कर देंगे वॉल्यूमेट्रिक फ्लास्क में, उसे डिसॉल्व कर देंगे एंड देन अकॉर्डिंग टू द स्पेसिफिकेशन विल स्टार्ट फॉर द चेकिंग ऑफ ऑप्टिकल रोटेशन ऑफ दैट पर्टिकुलर कंपाउंड. सो अ पोर्शन ऑफ द सॉल्वेंट इज यूज्ड फॉर अ ब्लैंक डिटर्मिनेशन. ये तो आपको पता ही है कि जब भी हम किसी भी सैंपल का एस्टिमेशन करते हैं वी ऑलवेज कीप वन ब्लैंक. ओके, द सैंपल सोल्यूशन इज फिल्ड इन द सैंपल ट्यूब. दो ट्यूब्स होते हैं हमारे पास, एक सैंपल के लिए होता है, एक हमारा रेफरेंस के लिए होता है. तो सैंपल ट्यूब में आप अपना सैंपल फिल कर देंगे. केयर शुड बी टेकन so that the end window will not be stained while screwing the caps. So after doing this, any bubble that may appear in the sample tube should be accommodate in the bubble trap at the center of the tube. तो जब आप अपना solid का जो ये फॉर्म बनाते हैं इसमें आपको क्या ध्यान देना है कि at the time of formulating this the bubble should not form inside that, because due to the presence of that bubbling the transmission of rays will affected and that affect your optical rotation of a particular compound. Okay, so you should take this in consideration while taking any solution into the sample set, that bubbling should be avoided. If bubbling is there, then try to remove that bubbling or reinsert your sample to have a proper optical rotation of a given compound. Okay. So, complete filling of the sample tube is essential. It is better to use long sample tubes to get maximum differences in the optical rotation between two samples. Okay. So, to get a proper optical rotation of any sample, the thing is that long sample tubes, or we can say maximum amount of the sample should be there so that we have a proper optical rotation of the sample. Okay, or complete filling should be there to have a proper optical rotation. Light source is usually as a sodium vapor lamp. What we have, जो हमारे पास इससे पहले था कि जो ऑर्डिनरी लाइट थी तो उसमें हम क्या करते हैं, सोडियम वेपर लैंप हम यूज करते हैं. On introducing an optically active sample between the polarizing elements, the balance is disturbed. Okay, it is necessary to rebalance by turning the analyzer. At that point when we introduce any kind of optical active substance between the elements, the balance between the elements will be disturbed. So, to maintain that balance, what we have to do, we have to rebalance the elements by the help of the analyzer. The extent to which the scale is rotated is a direct measure of the sample's optical activity. Okay. So, a sample tube which contains the test liquid, that is in solution form, it is placed between two polarizing elements, okay, that is Polaroid strips, or we can say calcite crystals. The first element, the polarizer, polarizes the light before it passes into the sample. The second element is the analyzer, that can be rotated to counteract any rotation by the sample and hence locate the resultant angular position of the light plane and hence the amount of rotation caused by the sample. So, by this phenomena we can identify the optical rotation of the compound. Now, what is the magnitude of rotation and what it depends upon the following factors? What are the factors on which it depends? So, now we are discussing few points, that the magnitude of rotation which depends upon the following factor. The first factor is the nature of the substance, कि substance का nature कैसा है. Okay. Next, length of the liquid through which light passes. जिस light से sample को pass करना है उसका length कितना है, ठीक है. Next, concentration of the solution. अब solution का concentration कैसा है, it is highly concentrated, okay, or it is balanced, or it is neutral, or what, okay. Then next, nature of the solvent. The solvent which is used to make a solution of a solid compound, then what is the nature of the solvent. Then temperature of the solution is also a very important parameter. What is the temperature of the solution? Okay, because temperature can also affects the optical rotation of that particular compound. Now, wavelength which is used in the form of light, okay, light wavelength which is used, if the light wavelength is not proper, optical rotation of that compound will not be identical, okay, or it may be affected. So, the wavelength of light which we use to identify the optical rotation of a certain compound, that the wavelength of light should be appropriate for the proper identification of the compound. Now, the rotatory power of given solution is generally expressed as specific rotation. It is the number of degree of rotation of the plane polarized light which is produced by 1 decimeter in length, which is filled with a solution having 1 gram of substance per ml. Okay. Then the measurement is carried out at a temperature T using sodium light, and the specific rotation can be calculated by the following relation. So, to identify any specific rotation of a compound, we use the formula. So, here alpha is denoted to observation angle of the rotation, L is identical to the length in decimeter, C is equals to grams of substance in 100 ml of the solution. So, this is the formula which is mentioned, alpha T by pi is equals to 100 alpha upon L into C. Here L is the length in decimeter, C is the gram of substance in 100 ml of this solution, and alpha is the observation angle of the rotation. So, by this we can identify the optical rotation of a compound. Okay. Now, what are the application of optical rotation? Okay. Applications क्या क्या हैं आपकी optical rotation की? A convenient method for study of optical isomerism, configuration and conformation of the compound. The first application is this कि अगर हमें किसी भी compound का optical isomerism फाइंड करना है, उसका configuration देखना है या फिर उसका conformation देखना है, then we can use the optical rotation. Okay? If the specific rotation of the sample is known, the concentration of optically active substance in the solution can be calculated alternatively. Okay? अगर मान लीजिए किसी भी सैंपल का हमें स्पेसिफिक रोटेशन पता है, ठीक है, तो जो उस सैंपल की कंसंट्रेशन होगी या उस सब्सटेंस का ऑप्टिकल एक्टिविटी होगा, उसको हम कैलकुलेट कर सकते हैं उनकी ऑप्टिकल एक्टिविटी को अल्टर कर करके, ठीक है. देन if the concentration of the material in the sample is known, the specific rotation can be calculated and used for the identification purpose. अगर हमें किसी भी मटेरियल का कंसंट्रेशन पता है तो हम क्या कर सकते हैं, उस मटेरियल की हेल्प से स्पेसिफिक रोटेशन को कैलकुलेट कर सकते हैं. अगर कोई भी हम ऐसा आइडेंटिकल पर्पस कर रहे हैं, अगर हमारा कोई भी आइडेंटिकल पर्पस है तो किसी भी मटेरियल की अगर हमें कंसंट्रेशन पता है, ठीक है, इफ वी नो द कंसंट्रेशन ऑफ द मटेरियल, then we can also identify the specific rotation of that particular compound. Okay. Now, quantitative method of analysis by polarimetry are widespread, particularly for plant control in the pharmaceutical industry. Another thing is that another application is कि quantitative method हम use कर सकते हैं, ठीक है, in the plant control pharmaceutical industry. The most extensive application is in the sugar industry. So, where it is highly used means where it is highly used application of optical rotation, that is in the sugar industry. Okay. In other application, the example is R&D, that is research and development. Okay. The user may be required to be fully conversant with the principle and to be in a position to investigate optical property of the test material. Possibly it is for the first time only. Okay. So, here are few compounds. You can see the compounds are mentioned here like sucrose, dextrose, digoxin, amethylene HCl and ephedrine HCl. ठीक है. So specific rotation is also mentioned, concentration, percentage in weight by volume is also given, and the solvent and other comments are also there. So I will discuss one by one. That first we take our sucrose. The specific rotation is plus 65.9. Okay. Then concentration in weight by volume is 20, and the solvent which we use, that is water. Likewise, we have dextrose, okay, that is plus 52.5 to plus 53.0. Concentration जो रहेगी weight by volume में, that is 10, and water containing 0.2 ml of ammonia solution, that is the solvent. Okay. Likewise, others are also mentioned. Digoxin is also there. Digoxin में जो हम concentration लेंगे weight by volume का, that is 10, and the solvent which we use, that is pyridine, using mercury light, okay, at 546.1 nanometers. Now emetine HCl, इसमें जो आपका concentration होगा weight by volume में, that is 6, and water we use as a solvent. एफिड्रिन HCl में भी आप concentration जो लेंगे वो 5% का लेंगे, और water आपका solvent system रहेगा. ठीक है. As when certain organic liquids or solution like sugar or other quartz crystals are placed in the path of plane polarized light, the plane of polarization is rotated. Okay? तो जैसे ही आपकी ये लाइट पड़ती है, तो प्लेन, जैसे ही प्लेन पोलराइजेशन लाइट किसी भी प्लेन पे पड़ती है, तो वो रोटेट करना शुरू करता है. एंड द प्रॉपर्टी ऑफ वर्च्यू ऑफ विच द प्लेन ऑफ पोलराइजेशन ऑफ लाइट इज रोटेटेड इज कॉल्ड एज ऑप्टिकल activity, and the substance which possessing the property are said to be optical active. Okay, optically or optic active substance. The substance which are rotate the plane of polarized light towards the right. Okay, जो आपने पहले पढ़ा है डेक्स्ट्रोरोटेटरी और लीवोरोटेटरी, क्लॉकवाइज और एंटी क्लॉकवाइज, दैट इज द थिंग कि अगर हमारी जो बीम ऑफ लाइट है, प्लेन ऑफ पोलराइज्ड लाइट, अगर वो हमारी पड़ती है, ठीक है, तो अगर डेक्सो रोटेटरी होगा तो क्लॉकवाइज मूव करेगा, और अगर लिवो रोटेटरी होगा तो इट विल मूव एंटी क्लॉकवाइज, ओके, इन अपोजिट डायरेक्शन. मल्टीपल ऑफ दीज टू वेराइटीज इज इक्वल इन द प्रोपोर्शन will be a optically inactive called racemic mixtures. These are the racemic mixture. Now chemical nature of substance like optical activity. The chemical nature of the substance is only responsible for exhibiting the optical activity. These are given below, like molecules having a asymmetric center about the single plane are optically active. Molecules that are not superimposable, okay, एक के ऊपर एक नहीं आ सकते हैं, ऑन द मिरर इमेजेस, सेम मिरर इमेज नहीं है तो सुपर इम्पोज नहीं करेंगे, मिरर इमेज होगी तो वो सुपर इम्पोज कर जाएंगे. कायरल सेंटर और कायरल कार्बन इज अ कार्बन अटैच्ड बाय 4 डिफरेंट ग्रुप्स. द एग्जांपल इज लैक्टिक एसिड, और लैक्टिक एसिड का जो आप स्ट्रक्चर है वो कैसे होता है आपका, दैट इज सी हियर, you can see on the blackboard that it is H bond, this is OH bond, this is COOH bond, and here it is CH3. So this is the formula or structure of your lactic acid compound. Okay. Next we have the chemical nature. Again, though the compound possesses a chiral centers, because of symmetry the compound loses optical activity. Meso 2,3 dichlorobutane optically not active due to plane of symmetry. Okay, so in this what we have the structure likewise here. Okay, you can see this here, this is C. Okay, likewise here we have CH3, this we come to Cl, and this we come to, this is Cl, and there we come to your C bond, H bond, sorry. Okay, likewise moving to this, it is C, this is to Cl, here it again come to H, this is come to CH3. So this is the mirror image, superimposable likewise. Okay. Moving to the next, factors influencing the specific rotation. What are the factors? The first factor is specific rotation depends on temperature and wavelength of light source. Okay, that is called as lambda. Normally light source is mercury, vapor lamp or sodium lamp, that is 589 nanometer. Optical rotation, unless otherwise mentioned, is measured at the wavelength of D line of a sodium at 25 degrees Celsius and on layer 1 decimeter in thickness. Okay. So, here one question is already mentioned, and the question is like the specific rotation of aniline is plus 14.7 degrees Celsius. If its optical rotation is 20 centimeter cube is 1.7 degrees 7 degree, then what is the concentration of aniline in the solution? So, you can say what we have, we can say alpha, that is equals to, I am going to solve this, that is 14.7 degree, ये मेंशन किया हुआ है आपका, ठीक है, 14.7. Now alpha is equals to your 1.7 degree. Next thing that, okay, and your L is equals to, what is L? That is 20 सेंटीमीटर, और दिस विल इक्वल्स टू, अगर आप इसको बोलना चाहें तो इट विल कम्स टू 2 डेसीमीटर. ठीक है, फॉर्मूला तो इससे पहले हमने देखा ही था ना कि अल्फा जो इससे पहले वाला हमारा फॉर्मूला है ऑप्टिकल रोटेशन वाला, आई कैन रिमाइंड यू वंस अगेन, दैट इज व्हाट, अल्फा टेम्परेचर बाय लैम्बडा इज इक्वल्स टू 100 अल्फा अपॉन L into C. So, by this we are going to solve this question here. Okay. So, I have already mentioned. So, here we have to find C. हमें फाइंड क्या करना है इसमें कि कंसंट्रेशन फाइंड करनी है एनालिन सोल्यूशन की. अब हम फाइंड कैसे करेंगे? विल मेंशन अल्फा दैट इज इक्वल्स टू 100 अल्फा ओके एल सी. ओके, यही तो चीज थी. सो और आप इसको लिख सकते हो C इज इक्वल्स टू 100 अल्फा upon the second thing L, in bracket you can mention alpha. Okay. So, here we are putting the values. C is equals to 100, alpha value is into 1.7, okay, by this, and on the below that is 2 point, what is the length, that is 2 decimeter, हमने वहाँ कर लिया था, तो 2.14 to 1.7 आपका second value of alpha. Okay. So, if you calculate this, the answer will comes to 5.8. Okay, or simply you can say 5.8, you can say 5.78. Okay. So, I am written as 5.8 grams per 100 ml. So, this is the concentration of aniline in the solution we have already calculated. So, likewise you have various problems for specific rotation and you can solve this accordingly. Okay. So, with this I have completed this topic, that is optical rotation. Okay. So, hope you would understand, you would like this class. Thank you and have a good day.